Module 3, Section 1, The Reality Code of Symmetry. According to the FBT theorem, our perceptions tend to hide reality. It can be explained in the following way. Our perceptions have been shaped in the process of evolution. That is the process of natural selection. With that said, people tend to assume that natural selection favors accurate perceptions of reality in order to survive in this world. However, according to the analysis of perceptual evolution, which is based on evolutionary game theory, accurate perceptions of reality tend to lead us to extinction. In other words, in the process of natural selection, our perceptions need to hide reality in order to survive. Donald Hoffman, who is the author of the book, The Case Against Reality, explained this mechanism in the following way.
Suppose you're writing an email, and the icon for its file is blue, rectangular, and in the center of your desktop. Does this mean that the file itself is blue, rectangular, and in the center of your computer? Of course not. The color of the icon is not the color of the file. Files have no color. The shape and position of the icon are not the true shape and position of the file. In fact, the language of shape, position, and color cannot describe computer files. The purpose of a desktop interface is not to show you the truth of the computer, where truth, in this metaphor, refers to circuits, voltages, and layers of software. Rather, the purpose of an interface is to hide the truth, and to show simple graphics that help you perform useful tasks, such as crafting emails and editing photos. If you had to toggle voltages to craft an email, your friends would never hear from you. That is what evolution has done.
Then, what is reality? According to the FBT theorem, which is the theorem of fitness for survival, beats truth. Even space and time are not fundamental aspects of reality. In the Hoffman's metaphor, space is represented by the computer screen. Therefore, that is not reality. According to this theorem, the most fundamental reality is a code that is used for data compressing and error correcting for fitness. In other words, there is a fundamental code for simplifying and maintaining the system of our perceptions. Data compression is needed for managing a lot of information. According to the FBT theorem, symmetries are needed for data compression. In other words, by using symmetries, we can reduce the amount of information. For example, when an object has the right-left symmetry, we don't need the information of both sides. That is, by knowing the information of one side, we will be able to know the information of the other side. Symmetries are also needed for error correction. That will be discussed later. In this section, we will focus on the fundamental code of universal symmetries.
Symmetry, Part 1.
In this figure, 0 represents emptiness or nothingness. When the universe was created from nothingness, equal amounts of particles and antiparticles were produced. A particle and an antiparticle have exactly the same mass, but they have opposite charges, representing yin and yang. Matter, which represents yang, is composed of particles. On the other hand, antimatter, which represents yin, is composed of antiparticles. This universe is made up of matter, not antimatter. Then, what happened to antimatter? That will be discussed in this section, in conjunction with personality types.
Note:
Antimatter is different from dark matter. The isomorphism between dark matter and personality types will be discussed in section 4. Particles, as well as antiparticles, are categorized into fermions and bosons, as illustrated. Fermions are material particles, and bosons are force carrier particles. The gravitational force and the electromagnetic force, for example, are caused by force carrier particles. The isomorphism between fermions and personality types will mainly be discussed in this section. Then, the isomorphism between bosons and personality types will mainly be discussed in the next section. As discussed in the introduction, isomorphism is a similarity of form. It is a one-to-one correspondence between the elements of two or more groups. By finding the isomorphism between elementary particles and personality types, we will be able to use the knowledge of particle physics to analyze personality types, and vice versa. In this way, we can build a bridge between physics and psychology.
3 generations.
Fermions, which are material particles, have three generations, as illustrated in this figure. A generation is a set of elementary particles. The first generation is the lightest, and the third generation is the heaviest. The term, generation, is related to the order of discovering particles. For example, the first generation particles, the lightest particles, were discovered first. As we will see later, this structure will be transformed into that of the Zeptoform.
CP symmetry.
CP symmetry is the combination of C symmetry and P symmetry. It is considered to be a fundamental code of the universe. First, we will discuss C symmetry. Particles and antiparticles have equal and opposite electric charges. Then, because particles and antiparticles were created in equal amounts at the beginning of the universe, there was the symmetry between positive charge and negative charge. It is the creation of C symmetry. C stands for charge conjugation. Next, we will discuss P symmetry. A particle can have the left-handed spin or the right-handed spin, as illustrated. A thumb in the figure represents the direction of traveling. Then, the other four fingers represent the direction of spin. At the moment of pair production, a particle and its antiparticle have opposite spins. When a particle has the left-handed spin, its antiparticle has the right-handed spin. When a particle has the right-handed spin, its antiparticle has the left-handed spin. This is one type of P symmetry.
Note:
After the pair production, particles as well as antiparticles constantly flip left and right, as illustrated in this figure. The function of spin will be discussed in the next section. There is another way to illustrate P symmetry. Suppose we take a picture of natural scenery and reverse the right side and the left side of the landscape in that picture, creating a mirror image. In this case, only those who have seen the original scenery can tell if it has been reversed or not. In other words, the laws of physics function in the same way for the left and right, and thus we cannot tell the reversal. This spatial symmetry of right and left is called P symmetry. P stands for parity. We have discussed two different types of symmetries, C symmetry and P symmetry. C symmetry is the symmetry of positive charge and negative charge. It can be seen as the symmetry of yin and yang, or yang and yin. On the other hand, P symmetry is the symmetry of left and right. It is the symmetry of space. The combination of C symmetry and P symmetry is considered to be one of the most fundamental codes of reality.
CP violation.
As discussed previously, when the universe was created from nothingness, equal amounts of matter and antimatter were produced. It is the creation of CP symmetry. But, in the next moment of the creation, matter became dominant over antimatter. In other words, the symmetry between matter and antimatter was violated. It is called CP violation, or the violation of CP symmetry. In order to show the mechanism of CP violation, we use the structure of quarks. As already discussed, particles are divided into fermions and bosons. In this section, we are analyzing the isomorphism between fermions and Enia types. Fermions are categorized into quarks and leptons, as illustrated. Quarks can be considered the core of matter, because the core of an atom is made up of quarks. On the other hand, leptons are not the central components of matter. For example, electrons, which are one type of lepton, are moving around the core. Also, the mass of an electron is negligible, compared to the mass of an atom. Therefore, in this section, we focus on quarks. Leptons will be discussed later. Quarks have 6 different types, as illustrated in this figure. Red represents positive charge, and blue represents negative charge. The bottom quark of the third generation can be changed to the up quark of the first generation, as illustrated. At the moment of this generation change, CP violation happens. That is, in order for CP violation to happen, 3 generations must be required. For this theoretical discovery, 3 scientists won the Nobel Prize in Physics. However, some of you might be thinking the following. CP violation is the violation of symmetry between particles and antiparticles. But, we discussed only particles, or quarks. So, what is the violation of symmetry between quarks and antiquarks? It can be explained in the following way. As discussed, the bottom quark is changed to the up quark. Likewise, the anti-bottom quark is changed to the anti-up quark, as illustrated in the right figure. However, these processes are not perfectly symmetrical. There is a frequency gap between these two processes. That is the violation of CP symmetry between particles and antiparticles. Also, we can see the following pattern. The CP violation of matter and antimatter is archetypically reflected onto the world of matter. That is, within the world of matter, not between matter and antimatter, there is the violation of symmetry between yin and yang. As we will see in this video series, in this world, in many domains, yang qualities tend to dominate yin qualities. Here is one example. A right hand represents yang, and a left hand represents yin. And many people are right-handed. Also, according to many psychologists, such as Susan Cain, about 2/3 of the people are extroverts. That is, in terms of quantity, extroverts dominate introverts.
Note:
according to MBTI manual, the population of introverts has been increased from 1/4 to 1/2. However, this change is superficial. The reason will be explained in Module 5. The fundamental pattern of CP violation is represented by this figure. That is, in this figure, positively charged quarks dominate negatively charged quarks. It represents the archetypical pattern of CP violation. Here is another example. A proton, which is the core of an atom, is made up of 2 up quarks and 1 down quark. That is, a proton is made up of the first generation particles. The up quark has a charge of plus 2/3, and the down quark has a charge of minus 1/3, and thus the total charge of a proton is plus 1. As we can see, within a proton, the yang quality dominates the yin quality. As discussed in this section, symmetry is the symmetry of yin and yang, or negative charge and positive charge, and it is violated in the universe. Likewise, in the structure of the Zeptoform, symmetry is violated by point 1. In this figure, the left side represents particles, and the right side represents enneatypes. As illustrated in the right figure, point 1 is changed from introvert to extrovert, or yin to yang. In addition to symmetry, p-symmetry, which is the left-right symmetry, is also violated in both elementary particles and personality types. In the case of personality types, geometrically, the relationship of left and right in the instinctive center is violated by point 1. This figure was discussed in Module 1, Section 1. As we can see, point 1 violates CP symmetry by moving up from the instinctive level to the thinking level. Likewise, when the bottom quark in the third generation is transformed to the up quark in the first generation, CP violation happens. When this theory in physics was proposed in 1973, only 3 types of quarks had been found. The third generation was missing. In order for this theory to be valid, the third generation needs to exist. By 1995, the other 3 types had been found, the third generation was discovered. For this theory, the Nobel Prize in Physics 2008 was awarded to 3 scientists: Yurichiro Nambu, Toshihide Masukawa, and Makoto Kobayashi.
The meaning of CP violation.
When particles and antiparticles clash with each other, their charges cancel each other out. At the same time, particles and antiparticles disappear, matter and antimatter cease to exist. Therefore, CP violation is required for this universe to exist. Because of this, some scientists have said, CP violation was caused by God's will, in order to create and maintain the universe. Related to this, point 1, which causes CP violation, represents God's will. In this figure, we can see the ratio between extroversion and introversion of each enneatype. For example, in the thinking center, type 7 is extroverted, and type 5 is introverted. Then, type 6, which is located in the middle of the thinking center, is an ambivert. By analyzing this figure, we will see the importance of CP violation. In this figure, there is no violation of CP symmetry in the instinctive center. That is, type 8 is extroverted, and type 1 is introverted. However, in this case, there is a problem with the connection between type 1 and type 2. As we can see in this figure, there is a gap between the location of type 1 and that of type 2. The problem with this gap can be explained in the following way. Type 1 with wing 2 and type 2 with wing 1 have the same components, the combination of type 1 and type 2. Therefore, in order for the Enneagram theory to be valid, these two types, type 1 with wing 2 and type 2 with wing 1, need to be similar in terms of extroversion and introversion. But, as we can see in this figure, these two types are totally different in terms of extroversion and introversion. Therefore, in order for the Enneagram theory to be valid, the violation of CP symmetry is required. In this figure, we can see CP violation. Because of this CP violation, the gap between type 1 and type 2 is eliminated. This figure will further be discussed in Module 5.
Symmetry, Part 2.
In the structure of the Zeptoform, the arrow of time is represented by the vertical direction. Then, the relationship between the arrow of time and the three generations of particles, which were discussed in Part 1 of this section, can be analyzed in the following way. Because kinetic energy is proportional to mass, higher energy can produce heavier particles. At the moment of the Big Bang, which has the highest energy density, heavier particles existed stably. But, as the universe expands, the temperature of the universe cools down, and heavier particles disappear. That is, the third generation particles, which are the heaviest, can be considered primordial particles, or extinct particles. This is why it was difficult to find the third generation particles. The top quark is the heaviest of all quarks. It has 0.31 zeptogram, and the diameter is 0.1 zeptometer. As discussed in the introduction, zepto is 1000 to the power of -7. As discussed in Part 1 of this section, a proton is composed of the first generation particles, which are the youngest generation particles. The term generation is related to the order of discovering particles. The third generation particles, heavier particles, were discovered last. But, in the case of excavation, the process of digging, the oldest fossils, which can be discovered last, are considered to be the first generation. That is, if the term generation is used in the way of archaeology, the third generation particles are considered to be the first generation, and the first generation particles are the third, as illustrated. In this way, we can see the consistency between the direction of time and generations. In this figure, the thinking center is illustrated in the Zeptoform. Type 6 is considered to be ambivert, which is the mixture of extrovert and introvert. Then, these qualities are divided into the extrovert of type 7 and the introvert of type 5. The former represents a particle, and the latter represents an antiparticle. Analogically, this structure corresponds to one type of phenomenon in particle physics. That is called pair production. Pair production is related to the creation of CP symmetry. Recall, C symmetry is the symmetry of yin and yang, and P symmetry is the symmetry of right and left. In this figure, the structure of the feeling center is illustrated in the Zeptoform. Type 2 is the extroverted feeling type, and type 4 is the introverted feeling type. Then, these two opposite tendencies are offset by each other, to create the tendency of type 3. That is, the people with the type 3 personality tend to dissociate from their feelings. As discussed previously, when a particle and an antiparticle collide with each other, both of them disappear. It is called annihilation. Type 3 is considered to be the most out of touch with feelings. Metaphorically, his feelings tend to be annihilated. In this figure, a hypothetical situation of the instinctive center is illustrated in the Zeptoform. That is, if there were no CP violation between point 8 and point 1, the process from point 8 to point 9, and the process from point 1 to point 9, superpose, and thus the instinctive center annihilates entirely. Therefore, the violation of CP symmetry is required for the instinctive center to exist. Because of this CP violation, the instinctive center has a different structure from that of this figure. That will be discussed later. According to particle physics, an antiparticle is going back in time. It is moving toward the past in the flow of time. When the antiparticle reverses its direction to the future, moving toward the future in the flow of time, it reverses its charge, and thus becomes a particle. From our usual perspective, this reversal can be seen as the moment of pair production. By analogy, the thinking center is illustrated in this figure. The direction of an introverted 5 is moving toward the past. When it reverses its direction to the future, it becomes an extroverted 7. This whole process is illustrated as sequential numbers 5, 6, and 7. By analogy, the feeling center is illustrated in this figure. A particle, which is represented by an extroverted 2, is moving toward the future. When it reverses its direction towards the past, it reverses its charge, and thus it becomes an antiparticle, which is represented by an introverted 4. This whole process is illustrated as sequential numbers 2, 3, and 4. In the instinctive center, there is the violation of CP symmetry, as previously discussed. Because of this violation, there is no reversal of time in the instinctive center, and thus there is no reversal of extrovert and introvert. The out and the in of the instinctive center are both extroverted. Therefore, in this figure, point 8 as well as point 1 represents a particle. Point 1 does not represent an antiparticle. As discussed, in the instinctive center, there is no reversal of time. But, in the middle of this center, which is point 9, time stands still, and thus the quality of neutrovert appears.
Note.
Point 6 represents ambivert, and point 9 represents neutrovert. The difference between ambivert and neutrovert will mainly be discussed in Module 5. In the process from point 8 to point 9, the quality of extroverted instinct vanishes. Then, the extroverted thinking appears at point 1. Point 1 does not represent an instinctive type, but a thinking type. This transformation from instinct to thinking represents quantum teleportation. Because of this, the process from point 9 to point 1 is not represented by sequential numbers. This teleportation can also be experienced as the teleportation to the supreme vertex, as illustrated. The supreme vertex was mainly discussed in Module 1, Section 4.
Note.
As discussed, an antiparticle is going back in time. That was claimed by Richard Feynman, who received the Nobel Prize in Physics in 1965.
The perfect symmetry.
In the structure of the Zeptoform, horizontal directions represent the dimension of space, and the vertical direction represents the dimension of time, as illustrated. Because time is represented by the vertical direction, the information about time is represented by height. The out and the in of the thinking center are located at the same height, as illustrated. Likewise, the out and the in of the feeling center are also located at the same height, as illustrated. In contrast to these two centers, the out and the in of the instinctive center are not located at the same height. That is, in the instinctive center, there is T violation, the violation of time symmetry. In addition to T violation, there is C violation and P violation in the instinctive center, as discussed previously. C symmetry is the symmetry of yin and yang. And point 8 and point 1 are not in the relationship between yang and yin, or extrovert and introvert. They are both extroverted. P symmetry is the symmetry of left and right. And, as we can see, point 8 and point 1 are not in the relationship between left and right. However, these three violations, C violation, P violation, and T violation, compensate for each other, in order to maintain the perfect balance in the universe. That is, in terms of totality, the universe has perfect symmetry, and it is called CPT symmetry. C symmetry is the symmetry of yin and yang. P symmetry is the symmetry of space, or left and right. And the T symmetry is the symmetry of time. The structure of CPT is considered to be the most fundamental code of reality. As already discussed, the three violations, C violation, P violation, and T violation, compensate for each other, in order to maintain the perfect balance in the universe. It can be seen as an error correction. With that said, as already discussed, the fundamental code of reality is needed for data compression and error correction. According to the CPT theorem, CPT symmetry holds for all physical phenomena in the universe. The perfection of CPT symmetry will be discussed from many different angles in this video series.
Symmetry, Part 3.
CPT symmetry is the perfect symmetry in terms of totality. Because there is CPT symmetry in the universe, when space and time are compressed into a single point, yin and yang in the universe would be totally annihilated. At the same time, the universe itself would be annihilated. This annihilation of totality can be analyzed in the following way. When point 1 goes back in time, the quality of yang is reversed to the yin. Therefore, when space and time are compressed into a single point, the yin and yang of the doing center, or the instinctive center, would be totally annihilated, as indicated by 0. Point 0 not only represents the annihilation of everything, but also the seed from which everything will be created. Then, there is a similarity between point 0 and point 9. That is, point 9 is also called the seed, or the seminal point. Almas said,
Traditionally, point 9 is seen as the seminal point in the Enneagram map, in that the other 8 points can be seen as different variations growing out of the experience of point 9. In other words, all other points have implicit within them the ground of point 9.
He also said,
Point 9 forms the center, out of which all the other points on the Enneagram, representing both holy ideas and the Enneatypes, emanate or differentiate.
Related to this, the process from point 9 to point 6, and to point 3, tends to imitate the creation process of the universe. It can be described in the following way. As discussed, point 9 is called the seminal point, or the seed. Then, the process from the seed to point 6 represents the pair production of particles and antiparticles. At this moment, the qualities of yin and yang are antagonized, matter and antimatter were created in equal amounts. Then, the process from point 6 to point 3 represents the violation of the three symmetries. That is, first of all, point 1 causes the violation of symmetries, as already discussed. Then, point 3 assimilates into point 1, and thus point 3 also represents the violation of symmetries. This violation represents the dynamic action of the universe. For example, a seesaw does not move when the same weight is applied to both ends of it. But, when the symmetry of the weight is violated, the seesaw begins to move. Point 3 represents this dynamic function of the universe, and it is called the functioning mode. This figure was discussed previously. As we can see in this figure, in addition to point 1, point 3 also represents the violation of CP symmetry. The process from point 9 to point 6, and to point 3, not only represents the process of creating the universe, but also the developmental process of a cell. It was discussed in Module 2, Section 1. Recall the following. Point 9 represents the stem cell. That is the earliest stage of a cell. Stem cells have not yet developed their own unique identity, and thus they are all identical. Related to this, type 9 is described by Riso and Hudson in the following way.
Their sense of self is undefined. Average nines have little sense of who they are, apart from those they have identified with, they see a little of themselves in all the types. Even relatively healthy nines still have a somewhat diffused sense of self, because it is based on their capacity to be receptive to others, and to be unself-conscious.
As discussed, stem cells are all identical. But, each stem cell has the potential to differentiate into various types of cells. It is called pluripotency. Related to this, as we will see in Module 7, the worldview of type 9 can be seen as the pluralistic worldview. The process from point 9 to point 6 represents the process of cell division. In this process, a stem cell is differentiated into different types of cells. Related to this, according to many Enneagram teachers, the variance among type 6 is the most noticeable. Finally, the process from point 6 to point 3 represents the creation of mature types of cells. Related to this, the process from point 9 to point 6 and to point 3 represents the developmental process of personality. As we have seen, the process from point 9 to point 6 and to point 3 represents many different types of developmental processes. It can be seen as the universal pattern of development. In this process, the violation of CP symmetry happens. As discussed previously, the violation of CP symmetry is required for the universe to exist, and it is represented by the structure of the Zeptoform. Therefore, we can infer that the Zeptoform can be used as the geometrical master archetype for integrating everything in the universe. This geometrical integration of everything will be demonstrated in this video series.
Symmetry, Part 4.
This figure was discussed in Module 1, Section 4. This color structure in this figure can be represented by the combination of the horizontal axis and the vertical axis, as illustrated. The color gradation of the vertical axis is created from the accumulation of the colors of the horizontal axis. This color structure, as the fundamental code of reality, will be discussed from here. According to the yin-yang principle, space is represented by the horizontal axis, and time is represented by the vertical axis. The time axis has a color gradation of red, orange, yellow, and clear light. This gradation is obtained by adding the spectrum from red to blue of the space axis. That is, the color gradation of time is created from the color gradation of space. In this relationship, we can see the following two pairs. On the space axis, the opposite side of red is blue. On the time axis, the opposite side of red is clear light. As we can see, on the time axis, the inverse symmetry between yin and yang is violated. That is, red and clear light are both yang. This violation of symmetry is caused by God's will, which is represented by clear light. The relationship between red and clear light is represented by the out and the in of the instinctive center, or beast in God. As already discussed, the instinctive center is changed from a horizontal structure to a vertical structure. That is the violation of CP symmetry. Space without time is static, which is yin. But, when the arrow of time is created from space, motion, which is yang, emerges. As we can see, space represents yin, and time represents yang. When the will of God, which is represented by clear light, creates time from space, the motion of the universe emerges.
Question.
Space represents yin. But, the left side of the space axis in the figure is not illustrated as yin. It is illustrated as yang. How do you explain that? That can be explained in the following way. For example, parents represent yin, and children represent yang. Then, children are created from parents. That is, yang is created from yin. But, in terms of the relationship between a father and a mother, not both of them are yin. Although, a mother represents yin, a father represents yang. A similar relationship can be seen in the relationship between the right and the left of the space axis. In the arrow of time, we can see the following structure. The background of the past is red, and that of the future is blue. Red is yang, and blue is yin. Then, the background of the past, which is red, appears in the arrow of time, but that of the future, which is blue, does not appear in the arrow of time, as illustrated. This means that, the past is explicit as it has already been experienced, but the future is implicit as it has not yet been experienced. Yang is explicit, and yin is implicit. As we can see, the past is yang, and the future is yin. But, although the future as blue indicates yin, the future as clear light indicates yang. This paradoxical duality will be discussed, step by step. At the bottom of the arrow of time, there is the darkness of infrared. This darkness indicates the state before the sun, or red, rises above the horizon, as well as the unknown elements of the beginning of time. Therefore, in this context, the past indicates yin. On the other hand, there is light at the top of the arrow. That is, the arrow of time accumulates all colors with the progress of time, and it ultimately becomes clear light. It indicates the following. Although we do not have any memory of the future, we can learn many things with the progress of time. We will be able to acquire more knowledge in the future, becoming explicit. Therefore, in this context, the future indicates yang. The warm color, which indicates yang, has longer wavelengths, and the cool color, which indicates yin, has shorter wavelengths. Clear light includes the whole range of wavelengths, and thus it indicates the totality of yin and yang. However, in terms of darkness and brightness, this totality indicates yang, brightness. That is, in order to embody true perfection, the darkness at the bottom and the brightness at the top need to be integrated. This is a geometrical realization of perfection. And, that is the realization of CPT symmetry. Module 3, Section 2, The Reality Code of Forces. In the previous section, we discussed the isomorphism between fermions and personality types. Then, in this section, we will find the isomorphism between bosons and personality types.
6 types of bosons.
As illustrated in this figure, bosons as elementary particles have 6 types. These particles are called the graviton, the photon, the gluon, the Z boson, the W boson, and the Higgs boson. The Higgs boson is an exceptional particle. That is, although the Higgs boson is one type of boson, it is not a force carrier particle. It is neither force carrier particle nor material particle. This categorization will be discussed later. The W boson in this figure is illustrated in the blue area. It indicates the negative electric charge of the W boson. As discussed in the previous section, a particle and its antiparticle have opposite electric charges. Therefore, the antiparticle of the W boson has positive electric charge. The other 5 types do not have electric charge, and thus they are exactly the same as their antiforms. This means that we cannot distinguish particles from antiparticles in these cases.
The gravitational force and the inertial resistance.
The graviton is represented by 0.7, and the Higgs particle is represented by 0.8, as illustrated. The graviton, or the gravitational field, produces gravitational mass. On the other hand, the Higgs particles, or the Higgs field, produces inertial mass. Gravitational mass is measured by the gravitational force between objects. It is the attraction between objects. On the other hand, inertial mass is measured by its resistance to acceleration. It is the resistance to the change of the velocity of an object. Although gravitational mass and inertial mass are different, according to the equivalence principle, the gravitational mass and the inertial mass of any object are equal. This was demonstrated by Galileo Galilei. It is said that he dropped two balls of different masses from the top of the Leaning Tower of Pisa. At the time, the majority of people thought that heavier objects fell faster than lighter objects because of gravitational mass. But the balls fell at the same speed and hit the ground at the same time because of inertial mass. That is, as an object gets heavier, the resistance to acceleration becomes greater, and the two masses, the gravitational mass and the inertial mass, create the perfect balance. As already discussed, the relationship between the graviton and the Higgs particle is represented by the relationship between type 7 and type 8. Because the graviton itself does not have mass, it can travel freely at the speed of light. It can be seen as a characteristic of type 7. On the other hand, because the Higgs particle has the heaviest mass among the 6 bosons, it symbolizes the grounding to the Earth. It can be seen as a characteristic of type 8.
Note:
as discussed in Module 1 and Module 2, both type 7 and type 8 are action types. According to the standard model of particle physics, every elementary particle, except the Higgs particle, has spin. There is left-handed spin and right-handed spin, as illustrated. The spin of particles constantly flips left and right, as illustrated. This pattern is caused by the Higgs field, and it creates inertia. From here, the mechanism of inertia will be described step by step. First of all, the Higgs field creates Higgs particles. Then, each Higgs particle decays into a particle and its anti-form. When a particle has right-handed spin, its anti-form has left-handed spin. When a particle has left-handed spin, its anti-form has right-handed spin, as illustrated. Then, these particles create new pairs, as illustrated. There is a right-handed pair and a left-handed pair. In each pair, a particle and an anti-particle have opposite directions of traveling, as illustrated. In this way, the net momentum of each pair becomes zero. Both the net momentum in the direction of travel and in the direction of spin become zero. These pairs can create inertia in the following way. First of all, the left-handed antiparticle collides with the right-handed antiparticle, and they annihilate. Because of this annihilation, only the right-handed particle remains. In this process, the left-handed particle is replaced by the right-handed particle, as illustrated. Next, the right-handed particle collides with the left-handed antiparticle, and they annihilate. Because of this annihilation, only the left-handed particle remains. That is, the right-handed particle is replaced by the left-handed particle, as illustrated. In this process, when a particle is replaced by another particle, it does not go straight forward, as illustrated. That is, a particle moves in a zigzag pattern, or random pattern, as illustrated. Therefore, the total speed to the initial direction decreases. In this way, a particle acquires inertial mass.
Note:
when a heavy object is moving, it is difficult to stop it because of inertia. That is a characteristic of type 8. That is, in some situations, type 8 is unstoppable. Massless particles, such as photons, do not interact with the Higgs field, and thus they do not change their spin. Left-handed photons are always left-handed, and right-handed photons are always right-handed, as illustrated. According to Einstein's relativity theory, the faster an object moves, the slower time passes. Ultimately, when the speed of an object reaches the speed of light, time stands still. When time stands still, change does not happen. The photon is traveling at the speed of light. Therefore, it does not experience any change, including the change of its spin. The photon is represented by point 1, and the holy idea of point 1 is holy perfection. Perfection indicates completeness, and thus it indicates the end of any process. That is the state of stillness. Brilliancy, which is the main essential quality of type 1, is the essence of perfection. Because of this, Almas said,
"Brilliancy is a presence that slows time to a standstill. When time stops, we experience timelessness, and the presence is pure and complete. The luminosity and magnificence of brilliancy is the exquisite perfection of presence without time. That is why, The full experience of brilliancy is the experience of timelessness.
The mass of any elementary particle is considered to be inertial mass. In this figure, the Higgs field is represented by red. The Higgs particle is directly produced from the Higgs field, and thus it has the heaviest mass among the 6 bosons. The Z boson and W boson interact with the Higgs field, and thus they acquire mass. These two particles, Z and W, have almost equal masses. The graviton, photon, and gluon do not interact with the Higgs field, and thus they do not have mass. As we can see, the mass hierarchy of the 6 bosons perfectly fit into the structure of the Zeptoform. As already discussed, inertial mass is related to the change of spin. However, the Higgs particle does not have spin. Then, how does the Higgs particle acquire mass? That will be discussed in Module 4. In that module, particle physics and music theory are integrated.
The electromagnetic force.
The electromagnetic force is mediated by photons. And the photon is represented by point 1 as illustrated. The brightness of light is determined by the number of photons. Related to this, the essential aspect of type 1 is called brilliancy, or clear light. Photons interact with electric charge, and this interaction is called the electromagnetic force. The electromagnetic force combines negatively charged particles and positively charged particles. For example, a proton has positive charge, and an electron has negative charge. These two particles are connected by the electromagnetic force to form a hydrogen atom, as illustrated. As we can see, the electromagnetic force combines negative charge and positive charge. It can be seen as the integration of yin and yang. Related to this, the essential aspect of type 1, which is brilliancy, represents the totality of yin and yang. In this figure, the warm color, which represents yang, is illustrated on the left side. On the other hand, the cool color, which represents yin, is illustrated on the right side. Warm colors have longer wavelength, and cool colors have shorter wavelength. Then, from the accumulation of all wavelengths, clear light, or brilliancy, emerges. It is the totality of yin and yang, and thus it is the representation of perfection. Related to this, the holy idea of type 1 is holy perfection.
Note:
Although the clear light represents the totality of yin and yang, in terms of the relationship between brightness and darkness, it represents yang. It means that, in order to represent ultimate perfection, the brightness needs to be integrated with the darkness. The integration of the brightness and the darkness will be discussed in this video series.
The strong force.
The strong force is mediated by the gluon. And the gluon is represented by point 5, as illustrated. The gluon interacts with color charge, blue, anti-blue, green, anti-green, red, and anti-red, and this interaction is called the strong force. Quarks have color charge, and thus the strong force can interact with 3 quarks to form a proton as well as a neutron. Also, it can interact with 1 quark and 1 anti-quark to form a meson. The types of color charge are not actual colors. But there are a lot of similarities between the system of color charge and that of actual colors. These similarities can be seen in the following way. The total color charge of a particle is always 0, and this totality is considered to be white, or clear light. In the case of a proton and a neutron, the 3 colors, blue, green, and red, are combined. From the combination of these 3 colors, white emerges, as illustrated. In the case of a meson, its colors can be seen in the following way. A meson is composed of 1 quark and 1 anti-quark. When a quark of the meson has the color charge of blue, its anti-quark must have the color charge of anti-blue. The net charge of blue and anti-blue is 0. Metaphorically, anti-blue can be seen as yellow, because the mixture of blue light and yellow light creates white, or clear light. In the same way, anti-green can be seen as magenta, and anti-red can be seen as cyan. The essential aspect of type 5, which is called the diamond guidance, can integrate various essential aspects, which have various colors, to form a diamond structure of essence. Likewise, the gluon integrates quarks, which have various color charges, to form a nucleus. That is, the structure of a nucleus can be seen as the representation of the diamond structure of essence.
Note 1.
As discussed previously, a hydrogen atom is composed of 1 proton and 1 electron, and a proton is composed of 3 quarks, as illustrated. These components are integrated by the electromagnetic force of type 1, and the strong force of type 5. This structure represents the structure of the brilliancy diamond. That is, as discussed in Module 1, Section 4, the brilliancy diamond emerges from the integration of brilliancy of type 1 and the diamond guidance of type 5. This figure represents the function of the brilliancy diamond. The perspective of type 1 tends to see clear light, and that is related to the function of the electromagnetic force. On the other hand, the perspective of type 5 tends to see various colors of light, and that is related to the function of the strong force. Type 1 tends to judge based on good and bad, or positive and negative. Related to this, the electromagnetic force interacts with positive electric charge and negative electric charge. On the other hand, type 5 tends to see many different essential colors. Related to this, the strong force interacts with various types of color charge.
Note 2.
The strong force works on the inside of the proton, connecting quarks. On the other hand, the electromagnetic force works on the outside the proton, connecting a proton and an electron. Related to this, type 5 is an introverted type, and type 1 is an extroverted type.
Note 3.
The Sun and the Earth are connected by the gravitational force, and the gravitational force is represented by type 7. The solar system is much more macroscopic than the structure of a hydrogen atom. Related to this, type 7 is more extroverted than type 1.
The weak force.
Z bosons and W bosons are called weak bosons. They are represented by point 2 and point 4, as illustrated. Weak bosons interact with a weak charge, and this interaction is called the weak force. The weak force can change one type of particle to another type of particle. The bottom quark of the third generation can be changed to the up quark of the first generation, as discussed in Section 1. This generation change is caused by the weak force. In this generation change, the weak force changes the electric charge of the quark from negative to positive. But, according to the principle of charge conservation, the total charge of the particles cannot be changed. That is, when the bottom quark of the third generation is changed to the up quark of the first generation, the W boson, negatively charged weak boson, appears, so that the total charge remains the same. The bottom quark has a charge of -1/3. And the up quark has a charge of +2/3. Therefore, in order to keep the principle of charge conservation, the W boson needs to have a charge of -1. Among the 6 bosons, only the W boson, represented by type 4, has electric charge, as previously discussed. As we have seen, the bottom quark is changed to the up quark by the W boson. Likewise, the anti-bottom quark is changed to the anti-up quark by the anti-W boson, as illustrated. However, these processes are not perfectly symmetrical. As discussed in Section 1, there is a frequency gap between these two processes. In other words, in this case, particles and antiparticles have different lifetimes. That is related to the violation of CP symmetry between particles and antiparticles.
Note 1.
Point 4 is represented by the W boson, as discussed. But, in the case of a quark, point 4 is represented by the strange quark. The strange quark has strangeness, which is one type of quantity. The value of the strangeness can be changed by the weak force. Other forces cannot change the value of the strangeness. Coincidentally, the term strangeness represents the characteristic of type 4. That is, type 4 tends to value the uniqueness, or originality, of oneself.
Note 2.
Point 2 is represented by the Z boson, as discussed. But, in the case of a quark, point 2 is represented by the charm quark. The charm quark has charmness, which is one type of quantity. The term charmness represents the characteristic of type 2. That is, type 2 is considered to be the most seductive type among all enneatypes. She tends to value a close affectionate relationship with others.
Note 3.
Some types of coincidence can be seen as synchronicity. That is, for example, when a person coins a term, such as the strange quark or the charm quark, the consciousness of this person might be receiving some kind of related information from the isomorphic field of archetypes.
The strong force, and the weak force.
As discussed previously, the strong force can integrate quarks to form a nucleus. On the other hand, the weak force does not integrate quarks. Instead, it changes quarks. Similarly, the inside of type 4 is less related to the integration of aspects, compared to the inside of type 5, and more related to the change of one's identity. This figure was discussed in Module 1, Section 1. The perspective of type 5, which is wholly omniscience, integrates many different types of essential colors. Related to this, the gluon, which represents type 5, integrates many different types of color charge. On the other hand, the perspective of type 4, which is wholly origin, penetrates different levels. Related to this, the W boson, which represents type 4, can change the generation of particles. In this section, we have discussed the isomorphism between personality types and bosons. Module 3, Section 3, Atomic Functions. This figure was mainly discussed in Section 1. In this figure, the highest level represents the component of a proton. A proton is composed of 2 up quarks and 1 down quark. These quarks are modern particles, not primordial particles. Related to the structure of a proton, the willpower of point 1 and the action power of point 7 are integrated by the inside of point 5, as illustrated. This integrated structure is analogous to the structure of a proton. The up quarks are positively charged, and the down quark is negatively charged. The former represents extroversion, and the latter represents introversion. The functions of these 3 enneatypes are encompassed by the functioning mode of type 3. Therefore, a proton can be represented by point 3. However, you might be wondering about the following. The functioning mode of type 3 includes the function of point 8. But this proton does not include point 8. The reason will be discussed later. When a proton is combined with an electron, it becomes a hydrogen atom, as illustrated. A hydrogen atom is the most abundant chemical element in the universe. As discussed in the previous section, a proton and an electron are connected by the electromagnetic force. The function of the electromagnetic force is represented by point 1. Having said that, point 3 superposes on point 1, and thus point 3 tends to use the function of the electromagnetic force.
Covalent bond.
2 hydrogen atoms can be connected by the covalent bond, as illustrated. The function of the covalent bond represents one of the main functions of type 3. That is the function of the pearl. As mainly discussed in Module 1, Section 3, the pearl works like an interface, through which we can communicate with other people effectively.
Note:
The electron has 3 generations. These are called the electron, the muon, and the tauon. Because the muon and the tauon are much heavier than the electron, they cannot exist stably. In other words, they are not used to form a hydrogen atom. However, there are some exceptions. For example, in a muonic atom, which is one type of exotic atom, an electron is replaced by a muon.
The weak force, and neutron decay.
In this figure, a neutron and a proton are represented by type 9 and type 3, respectively. Type 9 is a neutrovert, and type 3 is an extrovert. Related to this, the electric charge of a neutron is 0, and that of a proton is positive 1. Outside the nucleus, neutrons are unstable, and thus, a free neutron changes into a proton. In this process, a neutron emits a negatively charged weak boson, so that the process can keep charge conservation. As discussed previously, the weak boson, which is represented by type 4, causes the change of identity. The process from point 9 to point 3 can be seen as the dissociation from the function of the heart. That is, the functioning mode of point 3 is characterized by the dissociation from the feeling mode. Related to this, in the process from point 9 to point 3, the weak boson, which represents the function of feeling, is dissociated. The weak boson decays into 1 electron and 1 antineutrino, as illustrated. When a particle is moving toward the past, it can be seen as an antiparticle, as discussed in Section 1. Therefore, the antineutrino in this figure can be illustrated in this way. In this figure, a neutrino, not an antineutrino, is moving backward in the flow of time. This process is equivalent to the process in the next figure. In this figure, a neutron emits a negatively charged weak boson, and thus it becomes a proton. On the other hand, a neutrino absorbs a negatively charged weak boson, and thus it becomes an electron. As already discussed, the weak boson, which is represented by type 4, causes the change of identity. As discussed previously, the structure of neutron is unstable. Then, in the process from neutron to proton, the structure of the nucleus will be stabilized, Related to this, the hydrogen atom, which is made of one proton and one electron, is the most abundant chemical in the universe. Metaphorically, type 3 tends to use the function of an electron. That is called the covalent bond, as discussed previously. On the other hand, type 9 tends to use the qualities of neutrino. The function of neutrino is related to the function of empathy. Empathy is the ability to see the world from the perspective of another person. With that said, in order to experience the perspective of another person, the perspective of I, or the sense of my own identity, needs to be set aside. It is the characteristic of a neutrino, as we will see.
The neutrality of neutrino.
The neutrino is so named because of its neutralness. Its electric charge as well as color charge is zero. Also, its mass is almost zero. Because of this, it is very difficult to observe the behavior of neutrinos. The neutrino is almost undetectable. Likewise, one of the main characteristics of type 9 is neutralness. And he tends to have a vague sense of self. Because of this, type 9 tends to have difficulty in identifying his or her own personality type. Type 9 tends to dissociate from the out and the in of the instinctive center. The former is represented by the Higgs field of type 8, and the latter is represented by the electromagnetic field of type 1. That is, the neutrino, which is represented by type 9, rarely interacts with the Higgs field, and does not interact with the electromagnetic field.
Note:
there are many scientists who think that neutrinos do not interact with the Higgs field at all. In that case, neutrinos do not acquire mass from the Higgs field, but from a different mechanism. In addition to these characteristics, they do not interact with the strong force because they do not have color charge. However, they interact with the weak force. In other words, neutrinos have weak charge. The weak force is represented by type 2 and type 4, and these two types belong to the heart center. Related to this, in the structure of the Zeptoform, type 9 belongs to the heart center, as illustrated.
Note:
unlike other particles, the neutrino can change its identity without any external force, and that is called neutrino oscillation. When neutrinos are traveling through space, they change their generations. In other words, the neutrino oscillates its generation. The neutrino has three generations. They are called the electron neutrino, the muon neutrino, and the tauon neutrino. As discussed, the neutrino oscillates its identity. Related to this, the vagueness of identity is one of the most recognizable characteristics of type 9.
The nuclear force.
In the structure of an atom, protons and neutrons are connected by the function of meson, and that is called the nuclear force. A neutron, as well as a proton, is made of 3 quarks. On the other hand, a meson, which is illustrated in the middle, is made of 1 quark and 1 anti-quark, and it represents the quality of ambivert. As already discussed, a meson is represented by 0.6, and 0.6 represents trust. That is, protons and neutrons are connected by trust. The function of trust is the connecting force. Although mesons are composed of material particles, they are force carrier particles. That is, mesons are not fermions, but bosons.
Nuclear force and nuclear fusion.
When a neutron is combined with a hydrogen atom, it becomes a heavy hydrogen atom. It is also called a deuterium atom. The core of a heavy hydrogen atom is composed of 1 neutron and 1 proton, and they are connected by the nuclear force. A heavy hydrogen atom can be fused with another hydrogen atom, and it creates helium-3. This fusion, which is called nuclear fusion, produces massive energy, and this is what makes the sun shine. Related to this, helium is named after Helios, the Greek god of the sun. Nuclear fusion is different from nuclear fission. Metaphorically, the fusion represents integration, and the fission represents disintegration. Nuclear fission has been used for nuclear generators in our societies, and that is much more hazardous than nuclear fusion. In the case of nuclear fusion, there is no possibility of meltdown. However, the scientists on this planet have not yet invented the technology of nuclear fusion reactors.
Note:
in December 2022, for the first time, a nuclear fusion reactor has produced more energy than was used to cause the reaction. However, still, it is on an experimental level, not yet for commercial use. The process of nuclear fusion can be seen as the process from point 9 to point 3. In this integration process, the trust of type 6 as the connecting force, is essential. As discussed in the previous module, the essential quality of type 6, which is trust, needs to be connected to the body of truth, the heart of truth, and the mind of truth. In this process, the functioning mode of type 3 is connected to the empathy of type 9 and the strength of point 8 through the connecting force of type 6. That is, in order for type 3 to integrate the true strength of point 8, the trust of type 6 is essential. That was discussed in the previous module. This figure, which will be discussed in Module 7, represents the developmental levels of worldviews. In this figure, point 3 represents the rational level. On the rational level, our societies have created nuclear fission generators. This fission is represented by the fission between the functioning mode and the feeling mode. As discussed many times, the functioning mode of type 3 tends to dissociate from the feeling mode. It can be seen as the representation of nuclear fission. Then, in the process from the pluralistic level to the integral level, and to the superintegral level, the technology of nuclear fusion generators will be invented, from the perspective of holy law and holy hope, of type 3. This is the process from point 9 to point 3. As already discussed, the process from point 9 to point 3 represents nuclear fusion. However, in order to transform the fission of point 3 to the fusion of point 3, the function of point 6 is essential, as illustrated. That is, the trust of type 6 can be seen as the connecting force between a neutron and protons. As already discussed, a neutron and protons are connected by the nuclear force. And the nuclear force is represented by the function of type 6. As discussed in Module 2 and in this module, the process from point 9 to point 6, and to point 3, represents the developmental process of a cell. Then, if we reverse this process, it becomes the process of cellular reprogramming, which is also called nuclear reprogramming. That is, in this figure, the process from point 3 to point 6, and point 9, can be seen as the process of nuclear reprogramming. In the process of nuclear reprogramming, we can create pluripotent stem cells. As already discussed, point 9 represents the stem cell, and it has the potential to differentiate into various types of cells. It is called pluripotency. Related to this, the worldview of type 9 represents the pluralistic worldview, as illustrated. In the field of biology, cell fusion, which can be used to demonstrate nuclear reprogramming, has been accomplished. But, in the field of physics, the technology of nuclear fusion has not yet been achieved. Nuclear fusion represents the fusion between the womb realm and the diamond realm. The womb realm and the diamond realm were discussed in the previous two modules, and the integration of the two realms can be seen as the solution to the hierarchy problem in our society. Details will be discussed in Module 7. Module 3, Section 4, Theory of Everything. A theory of everything is a hypothetical theory in physics, which integrates everything, including the four forces, the electromagnetic force, the gravitational force, the strong force, and the weak force. There are some candidates for a theory of everything, and superstring theory is considered to be the best by many scientists. According to this theory, any elementary particle is not a particle, but a tiny string, called a superstring, which has the shortest possible length. This shortest possible length is called the Planck length. Then, the smallest possible time interval is called the Planck time. 1 Planck length is the shortest possible length. 1 Planck time is the smallest possible time interval. These units can be seen in the following way. The passage of time and the movement in space are not continuous, but discrete. Discrete means individually separate and distinct, such as a broken line. In 1 Planck time, light travels 1 Planck length, or a photon travels 1 Planck length. The universe was created from the void. Then, after 1 Planck time passed, the universe was 1 Planck length in diameter. At that moment, it had the Planck density and the Planck temperature. The Planck density is the highest possible density. The Planck temperature is the highest possible temperature. When the space had the Planck density and Planck temperature, a particle had the heaviest mass, which is called the Planck mass. This heaviest particle is called the Planck particle. When the string vibrates one time in 1 Planck time, it creates the Planck mass. That is, the string becomes the Planck particle. The Planck particle is a hypothetical particle. Because the Planck particle has the heaviest mass, it becomes a tiny black hole and disappears instantaneously by radiating its energy, called Hawking radiation. Therefore, no elementary particle can have a larger mass than the mass of the Planck particle. The Planck particle is represented by type 8. Then, the upper triangle in this figure is represented by type 1. That is, the fundamental idea of type 1 is perfection, and it implicitly includes all qualities of the 6 bosons. The essential aspect of type 1 is brilliancy, or clear light, and it includes all essential aspects implicitly. In this context, type 1 includes point 8 as the Higgs particle, as illustrated.
Note:
As discussed in section 1, according to the FBT theorem, space and time are not the fundamental reality. Recall the following. Donald Hoffman, who is the author of the book, The Case Against Reality, used the metaphor of a computer screen. That is, we are perceiving the computer screen as reality. According to him, in this metaphor, the Planck length is considered to be each pixel of the computer screen. In this module, we are analyzing the fundamental code of reality, which is behind the computer screen. As already discussed, the Planck particle and the Higgs particle can be represented by type 8 and type 1. Then, there is a fundamental question in physics.
Why is the Higgs particle much lighter than the Planck particle?
This question is called the hierarchy problem. In the Zeptoform theory, this problem is represented by the relationship between God and beast, as illustrated.
Note:
The Higgs particle is also known as the God particle. According to the standard model of particle physics, the Higgs particle should have a mass, which is close to that of the Planck particle. But, in reality, it has a much lighter mass than that of the Planck particle. That is the problem. Likewise, type 1 should be located on the instinctive level. But, it is located on the thought level. It is called CP violation, as already discussed. This problem can be solved in the following way. As already discussed, the hierarchy problem is the following question.
Why is the Higgs particle much lighter than the Planck particle? Or, why is the Planck particle much heavier than the Higgs particle?
The Planck mass is the heaviest possible mass of an elementary particle, and that is approximately the same as the mass of the Planck particle. Then, the question is, why is the Planck mass so heavy? The Planck mass is related to the inverse of the strength of the gravitational force. That is, as the gravitational force gets weaker, the Planck particle gets heavier. In other words, if the gravitational force is very weak, the Planck particle becomes very heavy. The gravitational force is the weakest force of all forces, weaker than the weak force. This is the reason as to why the Planck particle is much heavier than the Higgs particle. However, you might be thinking the following. How is the strength of the gravitational force related to the inverse of the Planck mass? The Planck particle has the heaviest mass, and thus it becomes a tiny black hole and disappears instantaneously, by radiating its energy, called Hawking radiation, as previously discussed. Therefore, no elementary particle can have a mass, which is larger than that of the Planck particle. Having said that, we can consider the following situation. As discussed in section 2, the gravitational mass and the inertial mass of any object are the same. But, let's suppose, these masses can be different, the equivalence principle can be violated. That is, when the gravitational force in the universe becomes stronger, only the gravitational mass of a particle becomes heavier. In this situation, the Planck particle becomes a tiny black hole faster than before, because of the larger gravitational mass, and it disappears before it gets a larger inertial mass. As we can see, as the gravitational force gets stronger, the Planck mass becomes lighter. In this way, the Planck mass and the gravitational force are inversely related. As discussed in section 2, the mass of any particle is considered to be inertial mass. The gravitational force is represented by type 7, and the Planck mass is represented by type 8. The action of type 7 brings about flexible action, flying in the sky. On the other hand, the action of type 8 brings about firm substantive action, grounding to the earth. In this way, type 7 and type 8 are inversely related. As we have seen, because the gravitational force is the weakest force of all forces, the Planck particle is very heavy, it is much heavier than the Higgs particle. However, this solution creates another problem. That is,
why is the gravitational force much weaker than other forces?
That will be discussed, step by step. According to superstring theory, there are open strings and closed strings, as illustrated. All particles are open strings, except the graviton. That is, The graviton is the closed string. Strings are vibrating in the 11-dimensional spacetime. Open strings move within the 10-dimensional spacetime. But, closed strings exceed this limit, and move in the 11-dimensional spacetime. That is, the graviton, which is a closed string, has the highest degree of freedom. Related to this, type 7, which represents the graviton, represents flexibility and freedom. This characteristic of the graviton is considered to be one possible solution to the hierarchy problem. As already discussed, the graviton goes into the extra dimension. Because of this, the effect of the gravitational force spreads into the extra dimension. The strength of the gravitational force is diluted. This is the reason as to why the gravitational force is much weaker than other forces. Consequently, because of the inverse relationship between the gravitational force and the Planck mass, the Planck particle becomes much heavier than other particles. This is the creation of the wide range of mass hierarchy. The gravitational force, hierarchical levels, and freedom are all related, as we have seen. Point 7 represents the gravitational force as well as the graviton, and the graviton does not have mass. Therefore, it is free from its gravitational force. The gravitational field creates the hierarchical levels of mass, and point 7 represents the freedom from these hierarchical levels. Without hierarchy, or force, the freedom from hierarchy, or from force, cannot be represented. Point 7 represents the number of basic elements for creating diversity, as discussed in Module 1, Section 2. That is, freedom, or liberty, tends to create diversity, including the diversity of hierarchical levels. For example, economic liberty tends to create hierarchical levels of wealth, as we will see in Module 7.
Supersymmetry, and dark matter.
The universe has more mass than the total mass of ordinary matter. This excessive mass in the universe originates from hidden matter, called dark matter. It is invisible, because dark matter does not interact with photons, which are the quantified elements of light. Some scientists think that superstring theory can be used to identify dark matter. The word super in superstring indicates supersymmetry. That is the symmetry between fermions and bosons, or material particles and force carrier particles. The isomorphism between fermions and personality types was mainly discussed in Section 1, and between bosons and personality types was mainly discussed in Section 2. Supersymmetry is the integration of these two groups. For example, a quark has a squark as its supersymmetric partner. The former is a fermion, and the latter is a boson. In the same way, a photon has a photino as its supersymmetric partner. The former is a boson, and the latter is a fermion. With that said, dark matter might be made up of supersymmetric particles. Then, in analogy, what are the supersymmetric partners of personalities? They are the dark side of personalities, and they are called shadows. In this section, we will see how we can discover the dark side of our psyche. Supersymmetric particles have much greater mass than ordinary particles. Having said that, in order to discover heavier particles, scientists need to create a lot of energy. That is one of the reasons why it is difficult to find supersymmetric particles. Scientists have not yet discovered a supersymmetric particle. In the same way, people have difficulty in finding supersymmetric aspects of their psyche. But the influence of these aspects is not negligible. Related to this, in this universe, the total mass of dark matter is much greater than that of ordinary matter. In this figure, we can see the 6 types of bosons. Then, in the next figure, the 6 bosons and their supersymmetric particles are illustrated. As already discussed, supersymmetric partners of bosons are fermions, and fermions are material particles. Therefore, they can be seen as the candidates for dark matter. In the simplest versions of supersymmetry theories, a particle and its supersymmetric partner have the same mass. However, because of spontaneous symmetry breaking, which will be discussed in the next module, supersymmetric particles have much greater mass. Therefore, in terms of the hierarchy of mass, their relationship can be illustrated in this way. Then, the Planck particle, which was discussed previously, is located at the bottom. The Planck particle is the heaviest particle of all elementary particles.
Note:
this figure was already discussed. The brightness at the top, and the darkness at the bottom, need to be integrated, in order to experience true perfection. It represents the integration of shadows. As already discussed, supersymmetric partners of bosons can be seen as the candidates for dark matter. However, not all of them are considered to be dark matter. Dark matter is dark because it does not interact with light. In other words, supersymmetric particles as dark matter should not have electric charge. In this way, we can narrow down the candidates for dark matter. A particle and its supersymmetric partner have the same electric charge. The W boson has electric charge, and thus its supersymmetric particle also has electric charge. That is, the we know, which is the supersymmetric partner of the W boson, is not a candidate for dark matter. By using the isomorphism between elementary particles and any types, we can further narrow down the candidates for dark matter. As discussed in Module 1 and Module 2, according to the Enneagram theory, the sleeping state of point 9 is considered to be the core of all mental problems. Because of this, analogically, the shadows of type 9 can be seen as dark matter. It will be analyzed step by step. Shadows can be divided into two major categories. One is called attachment shadows, and the other one is called avoidance shadows. Attachment is fixation, addiction, philia, grasping, etc. On the other hand, avoidance is alienation, allergy, phobia, rejecting, etc. Type 9 tends to be allergic to the out and the in of the instinctive center, or the beast and God. These elements are represented by type 8 and type 1. Also, type 9 tends to be addicted to the quality of a mother, which is represented by type 2. In terms of particles, these three types are represented by the photon, the Z boson, and the Higgs boson. Then, the supersymmetric partners of these three particles are superposed to create a new type of supersymmetric particle, which is called the neutralino. With that said, surprisingly, the neutralino is considered to be the primary candidate for dark matter. The neutralino is so named because of its neutrality of electric charge as well as color charge. Type 9 is the archetype of neutrality. The neutron, the neutrino, and the neutralino are all represented by type 9. Point 9 represents the sleeping state, as discussed many times. According to the Enneagram theory, the sleeping state of point 9 is considered to be the core of all mental problems. Almas said,
"The Enneagram of specific delusions is grounded in the delusion of point 9. In other words, each of the other 8 delusions can be seen as based on, or arising out of, this fundamental delusion. In some sense, your specific difficulty cannot be completely understood or resolved, until you resolve the specific difficulty of point 9. Similarly, your specific reaction cannot be worked through fully, until you resolve the point 9 reaction, which is that of falling asleep."
In order to wake up from the sleeping state of type 9, we need to integrate the dark side of our psyche. That is represented by the discovery of neutralinos. The integration of shadows will mainly be discussed in Module 8.
The creation of the universe.
As already discussed, at the beginning of space and time, the Planck particle was created. Then, the process from point 8 to point 7 can be seen as the Planck era. During the Planck era, which has the Planck time, there was only one unified force, which is called the superforce. At the end of the Planck era, the gravitational force, which is created by gravitons, was separated from the superforce. Because of this separation, the superforce became the grand unified force. Next, the strong force, which is created by gluons, was separated from the grand unified force. Because of this separation, the grand unified force became the electroweak force. Next, the Higgs field was activated. Because of this activation, weak bosons, Z and W, acquire mass from the Higgs field. It indicates the separation of the weak force from the electroweak force. Because of this separation, the electroweak force became the electromagnetic force, which is created by photons. The processes in this figure are all integration processes. That is, the algorithmic processes of the Enneagram theory perfectly represents the creation process of the four forces in the Higgs field. However, without using the structure of the Zeptoform, this correlation cannot be found. As discussed in this section, when the string vibrates one time in one Planck time, it creates the Planck mass. That is, the string becomes the Planck particle. Mass, charge, and other properties of a particle are determined by the vibrational state of the superstring. It is like a musical instrument. In the same way, the Zeptoform represents a musical instrument. That is, each point of the Zeptoform represents a different type of vibrational state. Because of this, the Zeptoform can be used to create music. That will be discussed in the next module. In the next module, music theory, personality theory, and physics are all integrated into one unified geometrical form.